would go to a video or a sheet like this and you would match them up. And keep in mind that when you're doing these, you're probably working for a firm where you're making these, or you got a big bolt bin somewhere, you're doing a lot of this. And so it gets to be second nature. I mean, you'll see a lot of people who are mechanics that have all this stuff memorized and they don't have to go to charts and they can just look at something and see it and they know exactly what it is. I think most of us have probably worked with somebody like that where we were younger or something, or go for them to say, hey, go get a 3/32 wrench and it fits every time, right? Those are the people that work with it all the time. Now the rest of us, like drafters, we don't deal with them every single day. Keep in mind what you want to be able to do is you want to be able to identify the fastener and the thread that goes with it, draw it, and put it on the drawing. For the most part, we don't really have to worry about too much about how it's going to perform. That's really what the engineer is supposed to do. I did see two of them that were wrong on almost everybody's, and it was under the nut types. The castellated nut and the slotted hex nut were the two that were mixed up, A and D. Now you can kind of tell the difference in that this D is actually a strength nut that uses a Carter pin to hold it. Right? What we do is we come through and we drill a hole in our bolt or our screw, turn the nut on, and we stick a wire or a Carter pin through those areas there, and it keeps them from turning. Okay? That's what this is for. Now, the reason this is the strength nut is that they put the locking device of the castellated area off of the nut. Okay. So you still got the full strength of the hex nut on top. Okay, that's your castellated one. The slotted hex is a standard hex nut, but then they've cut grooves in them for that same thing where we can then drill a hole through a fastener and stick a Carter pin through it, okay, and it will hold it in place. So these two got mixed up on your sheets.
Is that one not as strong?
No, it's not as strong because we've removed stuff off of the nut. You can kind of see how we've cut stuff out of the nut here, and here we've left the nut alone. But they both are locking nuts, one's stronger than the other. Were there any others on here that you were a little confused with? Sean, did you get squared away on what you need to do with this?
I don't have this yet.
Okay, you should have this on your desk somewhere. I tried to put everything in a pile last week.
What's G up there?
G's the machine screw.
And then
Yeah.
the G's doing a truss screw, wasn't there a, what do you call that, a truss screw or something? There was something that looked the same.
You're talking heads? Yeah, many of the heads look very similar.
Okay.
Okay, now G, the reason you know this is a machine screw is how come
It's threaded the whole way and
threaded all the way to the end and no chamfer.
okay.
That's a machine screw. And then what happens when you take a machine screw and you put a nut on it? We call that a stove bolt. Because they're all screws until you put a fastener with them. Did you find it?
Mm-hmm. I did.
So don't copy these down, Sean. There's a video that you'll get from me and you gotta go to the library and watch it.
Got it.
Get it from Missy.
Once you put the nut on it, it becomes a bolt.
Yes.
But what do you call that? It's a,
Stove,
and
right here.
why do they use stove? I mean, that's just a, why isn't it microwave one? I mean, I mean stove, it goes to stove, I mean, why, is that just a universal name?
Just a name.
It's the name they just came up with?
Yes.
Okay.
And didn't they talk about that those were originally used back on the old furnaces in the steel making business? And that's where they got their name, on a stove.
Is that where it came from? Okay.
But there's some interesting heads now. This might make a little more sense to you. Like Cheryl, you said it went in one ear and out the other. Okay, we just kind of want to know the generics. Today, we're going to pull out my little coffee can full of
That's a-
screw threads and nuts, and we're going to see if we can't figure out what some of these things are just by looking at them. Now, the second part, once we identify the type, okay, and how we want it to work, and keep in mind, until you get experience in the industry, a machinist or an engineer is going to tell you what you're using here. Okay? And then as you pick it up, then you say, oh yeah, I need that on here. Now, am I using this little blick head right here that fits in on all mow boards? Okay. Am I going to go with this square top that bites into wood? What am I going to do? Okay. So there's a lot of different options here. Yes.
For the most part, if we're going to a company, if they're using these all the time, won't they have a block that you just kind of have to
Yeah.
adjust a little bit? You would think
You bet.
you wouldn't do it from scratch as much.
That's right. Yeah, in fact, SolidWorks, Inventor, Pro E, all these have all the bolts already drawn for you. You just insert them in. Okay. Yes.
So on B, E, and F, they seem to have a little,
Are you down in the nut section?
yes,
Okay.
yes. They seem to have a little, like, top collar area.
Mhm.
What's the purpose of that?
Okay, they're all to hold those nuts on. So if you get a nut in a vibrating situation, they'll work themselves off. Okay, so we've got to have a way for them to hold it. Now, the old way, back when I was a young tyke, was we'd always put two nuts on. Okay, to tighten the first one down, then you take the second one and tighten it down to it, and that would hold it in place. Right? We called that a locking one. They've since got a bunch that do it on their own now. So you've got B, the first one. Okay? And that guy's a jam nut, right? Now, what did they do? What did they do on the jam nut to keep it so that it doesn't vibrate off?
Is it like coarse on top?
No? Remember what they did? You can kind of see it here. Okay, it looks kind of elongated. They made the hole an oval. It's not a circle. Remember that one?
When
It's
they
kind of
said
elliptical.
oval, I was like, it looks round.
Okay. And it's got more of an elliptical look here. I know it's an isometric mode and the circles appear elliptical, but that one looks a little different than the rest.
But it's more, is it like this?
Yes.
Where it cocks up? It's not?
No,
It's
it's
not
not
there.
cocked up. All they do is they take this and make this more elliptical shape.
The-
And so as you take the fastener on, this barely fits across the minor axis. And then as it goes on, it stretches that part and pulls the other side in and it holds it on. We call that a jam nut because they're next to impossible to get off. You need almost a air compressed wrench. Yes?
So when we're drawing ours, are we supposed to draw the chamfer in? See how
Okay,
it
let's stop for a second. We'll come back here.
Okay.
Now, there's a couple others on here. G, that holds itself, right? Okay, so that's where we put a little piece of nylon in there, and it cuts its own thread. Okay, those hold on also very nicely.
Oh, so the nylon's on the inside?
Yep, nylon's on the inside, it's sitting right underneath here.
it-
You'll see some
I
of these
missed
It
that.
cuts the
Okay.
thread?
in the nylon. Nylon's a
Oh,
soft
oh,
material.
Oh, I see what you're saying. Cuts it into.
Yeah.
inside.
Okay, and those are the two that are really kind of for that purpose. Now,
Okay.
let's go back to you, Lisa. You talked about a 45, or what were you dealing
Oh, yes,
with?
because see the bulkhead and the nuts and
we're up
bolts,
here.
they all, yeah, see if there's how they, on age, see it's chamfered?
Mhm.
Were we supposed to do that on ours, drawings?
Oh, when you draw on a bulkhead, yeah,
Oops.
that's what they are.
You guys
Yeah.
all get that?
There's a couple good examples on
I
this.
didn't do that.
I can show you where that's at when we switch to the drawing.
Because all these are differently.
Yeah, and there's examples on how to draw that too. Okay, we good on this sheet on the major parts?
How is C held in
This one, that's that one that's elliptical.
place? Oh, that's it, oh,
I thought B was looking.
No.
yeah. Oh.
Oh, excuse me,
You
no,
said
hold
Junior
on,
was.
B's the elliptical one. C is actually the one that like we got on a lug nut, right? The Stover nut? That one, it just seats itself, but this chamfered area, this is the same thing you use on your tires. And it's got one side chamfered so that it'll seat itself in a device. Does anybody in
Oh, so that
here
goes in.
not change the tire on your car?
I've seen it.
Okay. Yeah, yeah. Make it route, we don't change those tires, run all this stuff. They do it in the movies.
That is, that, oh, that's just a standard cut, it's not E.
E.
Explain why you would use F. Sorry, what's F for?
The F?
Yeah, F, that F, go for it.
Oh, this one right here?
Yeah. What's it called, a
Yeah,
valve?
that one's that's stamped out of metal, right?
Uh-huh.
It's a PAL. It's just a quick little device to keep things from sliding back out. They're really not for holding anything. They don't have any strength. They're in areas where you won't have much
Is that like
force
those,
applied.
like when you take your, like, talking about those stupid little things to keep the screws from falling off? Is that what that is?
Yeah, mhm, yeah.
That little teeny, okay.
It would be like that. It's not exactly like this
Right,
one,
something like that,
but it's
okay.
close, yeah. Same concept.
Okay.
The heads are the part I really struggled with, but I think all of you got every single one of those. Any questions on the hardness?
Yes,
Okay.
they had heavy and regular. Is it regular unless you see, unless it says it's heavy? I mean, all these,
No, I think the video said, if you do not know the strength of a fastener, what are you always to assume that it is?
heavy?
Nope.
I don't know, did you guys hear that one?
Heavy? That depends on the size, right?
I know.
Heavy is relative. Okay, so how do we figure out for the imperial system down here, how do we figure out the strength of a bolt? Actually, it's really the strength of the material used to make the bolt.
And little things on top.
Okay, you take the lines and what do you do with them?
Add some,
Add two,
add two.
right?
I'm
So
just-
they go up to an 8 is your hard one,
Okay.
is the strongest one. So I come into one like here, and the slash mark should always be symmetrical. Okay, so this one has 6, and I add 2, it's strength 8. Strongest one we make, available for the general public. I see this one right here, it's got 3 symmetrical marks.
There's-
That's, Wood River does 3 plus 2 is 6.
Oh, I was doubling it, no. That's fine. Yeah, well, we do it up there.
I thought it was just Kimberly where I went to
No, we
school.
do different up there, yeah.
That's a grade 5.
Oh, they just put 5 on it. Make it easy.
Okay, metric does that.
They give it to you.
Metric stamps a number. Okay, a grade 8 metric is equivalent to about a grade 5 in the imperial system. And a good medium strength fastener. I think a grade 12.9 or something is the hardest on the metric, somewhere in that range.
So if you had 2, that's how you get it.
Yes, Kate?
So I just have a question on bolt heads.
Up here?
Yeah, is the difference between C and A just the A is gonna be like bigger? Or is there,
CNA?
yeah,
Okay. This one's gonna be almost a true half circle. Okay, and that's the round one, right? C is the round. Okay, and then you come to A, which is your truss head. And
yeah,
this one's gonna be more elliptical, but it's got a little flat area right here also.
oh,
okay?
Oh, I guess that was.
And so it can also fit down inside of something and kind of lock itself in, like a counter board section.
okay. Yeah,
And it doesn't have such a high profile on the outside.
That
okay.
was-
Just in that picture, they look like the same thing.
Yeah, the truss and the pan. There's another one that kind of throws me on those also. I think it's this guy, because this one has a distinct flat section, and this is kind of a flat section. When you see it, they're hard to tell them apart when you're into them.
That looks like D.
Now-
That.
These
That
Phillips
was-
are,
that was bigger.
And these are actually bolts,
those are the heads.
heads.
I'm sure that would not take.
Okay, back to the strength. What strength is this one?
2, I can imagine.
0 plus 2. Now, if I come into a bolt and I see some that aren't symmetrical. So I'll see some that do, let's say it's got two like right
Is
there.
that like stainless?
5 different bolts.
Okay. Yes, you're right, Cheryl. If you have two marks on the top, but they are not symmetrical, it's a stainless steel bolt. Okay, I did put these into your mailboxes, those of you that haven't done, so you'll have those available to you in a couple minutes. Let's go to your drawing assignment. And I'll field any questions you may have, or at least give you where the information is at. So let's kind of take these in order. Number one. Did you understand that entirely? So you're drawing a 6-inch by 1-inch diameter steel shaft. It's all threaded. Has 1-8 UNC-2A threads on it. You're chamfering the right side only. And you're only drawing 1 inch of the threads on each end. Now we do use a convention here. And I wanted to point that out before we jump into it. So if you turn in your handout to page 393. And I'm looking at figure 1316. Because in essence, if we just take a shaft and we don't put a head on it, what do we call that? Stud. It's a stud. A threaded shaft without a head is a stud. And we can put different types of threads on each end. Now in this one, what you're doing is you're doing the same threads on both ends. You know, you're going to leave one end like a machine screw, one end like a cap screw, so they got the chamfer. And then, just so we don't have to redraw all those threads all the way through, I know on the computer it's not that big a deal, we just copy through. This is an old standard, we use phantom lines to show that the thread keeps going. So all you do is just chop your thread off and run a phantom line equal to your major diameter. And that is for displaying shafts. Okay, so kind of like this right here. Now, when we talk about the length of a fastener, whenever we deal with the length, what are we talking about? So here we called out a 6x1 shaft. Okay, so the length is 6. What if I called out a screw that's got a head on it, and I called it out as a 6-inch fastener? What am I dealing with on the length? What's that?
This is active bolt, after the head.
Yes, the usable part. So if I have one that's got a head on it and I call it out by 6, even if it's a cap screw, okay? So it does something like this. The distance is the distance from the thread to the clamping surface of the head. Now, if I was to put a washer face on here, okay, then that 6 would go to the bottom of the washer face. Okay, so we're always dealing with that length, and it's a usable part of the fastener. All right, so you see where that's from? That was kind of tricky to pick up. I should probably include that page number so you can see it. Your textbook does not talk about that, by the way.
Question.
Any other questions on number 1? Yes.
Yeah, your dimensioning of the 6, the length,
Yeah, right
the
here,
dimension line.
right.
You-
Because I turned a bunch of stuff off so you could see this better.
Oh, okay. That wasn't, because it has to be that way. Okay.
Now, you would have
Yeah,
true dimensions here.
okay.
Okay. All right, number 2, then. So here you're using simplified, and you're doing a drawing of a 3/4 -10 UNC -2A by 4.5 hex head bolt with a washer face.
So are we not supposed to connect the center lines on there? Or does it?
No, not between drawings, no. You mean right here, right?
Yeah.
No. All right, so where did you draw the head and the washer face? Where are you getting that information from? Your textbook, let me give you the page number. They have a bunch of head drawing stuff on page 928. In your handout, you start on page 401, and the examples kind of move through on all the different types.
And it's like the 30-degree chamfer.
Now, in essence, most of the proportions that you use on these are listed on page 402 of your handout. And I kind of like the handout for this because the handout puts them all in one place for you. Okay. So here you have all the proportions for your heads and stuff over here. So the width is 1.5 times the diameter. The H, which is your head, is 2/3 times the diameter. So is T. Your thread lengths are up here for your fasteners. 2 times the diameter plus 1/4 inch. And then following with some examples. You have those exact same proportions in your text on page 928. In this example here, where it's drawing a hex head bolt, and it's got a washer face on it. Now, I do want to clarify one thing on this. I got to find it. Here's the example on page 929 where they're running through everything. When they go to the washer face, it's on the next page, page 930, step 6. It's right here where you're drawing the washer face. It's represented as 0.02 inches thick. Okay. So that's a little, what you come down right here for the washer that we put on there. And it's just a little area that's left on the bolt head so that we don't need a washer. It's affixed to it and you never lose it when you take it off and it falls in the dirt. Okay. Now, don't do it at 0.2 though. Okay, go to a 16th because you're representing it. If you do it at 0.02, how's this going to appear on a drawing? It's just going to be a black line, right? At 200ths. An object line is 0.24 thick. Okay, so it's just not going to work. So do that where you're coming off a 6.1. Ew. 1/16. So come down off of the bolt head, 1/16. Okay.
I have a question about tolerances. You just, in the notes, is there a standard you just always put in, or is it?
You're actually, your thread note has all the tolerances it needs in it.
Okay.
Okay, because you'll call it out as, say, a 1/2 inch -8 UNC -28. Okay, you got classic fit, you got coarse threads, fine threads, extra fine, whatever. Okay. All your tolerances are built into the thread note. Okay, I think that's 2. Any questions on that one? Yes?
Are you supposed to dimension that little washer that's on the bolt on your drawing?
No, not usually. You just put with washer face on the thread note. Now, I'll put up the drawing here. This is 90% correct without a couple things turned
Oh,
off.
washer face textbook,
Okay.
okay, so you put it, okay.
Because the washer faces are a proportion, right?
Mhm.
Don't forget your diameter sign. These are all threads, right? They're diameter.